Okay, explain to me exactly what you're doing.
Okay, very simple. There's some junk. There we go. Okay, this is all just parts. Okay, what we have here is a Makita drill, $100, Home Depot. These are the batteries out of the Makita drill. Slides right in there. No big deal. 12 volt. 12 volt. This is my spare battery. I got little wires pushed into the end of the battery. I got a lead coming out here to a little RC motor that I bought at an RC place for little electric cars. Very tiny one actually. This is a 12 volt motor. This is an induction pump. This is off of a front load washing machine. This is what they use to pump the water out of it. I bought this myself on Kijiji. I paid more than I probably should have, but I understand they're about 55 bucks. Nothing special. Just got a permanent magnet, round one in the middle that goes through it, and it's just got two sets of coils, one here, one down there, and it spins and produces electricity. Here's the leads coming out. I ran them through a switch here, two switches actually. You can turn them on, off, and then I just wired it to the bulb. That's all I have right here. One lead comes in, goes to the bulb, and the other lead comes in and goes to the bulb. This is a 100 watt incandescent bulb. Is this the one that was burnt out? I think it is. Anyways.
Actually, where's the...
That's a 100 watt incandescent bulb. I'll grab another one here just in case.
Okay.
And screw it in. This is just your typical socket, right? This battery is actually getting low. I've been running it, so it's probably only putting out about 9 volts. This little motor, they couldn't even tell me what it spins at. It's probably spinning at 20,000 RPM when it's fully revved up. So basically all I'm doing, just straight leads, one to one side of the motor, 12 volt, right? Spin it up. There you go, it's spinning. Turn it on. Bulb lights up. Problem with these little motors is they have like a nylon bushings in them, that's it. So they won't withstand, they fall apart basically, right? You're spinning them at high speeds. But if you want to know where to get a better one, go to any hydroponics shop or a pond pump. They have magnetic drive pumps, actually hydroponic shops, magnetic drive pumps. Here in Edmonton I can buy one for about 139 bucks. I'm going to go over and pick one up. And they have bearings in them, so you haven't got this nylon bushing. They won't handle the high speeds, they melt. Anyways, all I did with mine was bought the little RC car, and I bought a little tiny gear for it, and I put it on. It's got an Allen key, tightened it up on the shaft, and used super glue. Glued it right to the end of the pump so it spins it. Away you go. This here is off my weed eater. This is a 19 volt battery, and no, this thing is not hooked up to any electrical. As you can see, there's nothing under it, right? Just this and the wires and the leads. I have a 12 volt wall charger I use sometimes so I don't keep killing my batteries, just for testing and things. I'll plug it in, hook it to the leads, away you go, right? And basically that's about it. It's no brain surgery, works 100%. If I hook this 19 volt battery up to this thing, just run it straight to here, spin this up. This little induction motor puts out off the back end about 420 volts. Right now with the 12 volt it'll put out about 200 and something volts. Seems like the higher the voltage is, if I run this at about 205 volts, a 12 volt fully charged battery, this bulb, when you do a test with your meter, okay, it seems like it draws about 20 or 30 volts. It'll drop from say 205 down to 187 volts, and she's bright as hell. Also picked up an LED bulb, is all this is. It's a $30 bulb. They're very expensive. You thread that in there and it only uses, this is 100 watt, this is 20 watt, lights it up just like a freaking flood lamp. No big deal. And the other thing that I found out by talking to Gerard on the phone is that all AC power coming into your house, 110, okay, now think about this folks, all the devices in your house are basically running on DC square wave, okay? Take your laptop. It's got a step-down transformer. I'm looking at my printer right now. It has a step-down transformer. And according to Gerard, most of your appliances in your house are stepped-down to DC square wave. So anyways, I think it's all a bunch of bullshit lie. Why would you need to feed 15,000 volts through a high-power line if all you really need is 110 volts to run your equipment. That he made a good point when he said that to me. Anyways, anybody who wants to try this, this is it works 100%. And this is there's no transformers. I haven't used a transformer here like Gerard does, and I have no transformers. I have no pig pole like on the video there. Nothing. Just straight out of the motor into the switch, into the light, away you go. Very simple. If these were 20-watt bulbs, for instance, I could light up 5 of them spinning this with a 12-volt battery. No big deal. Anyways, folks, that's it. So anybody who says it doesn't work, well, they definitely haven't done their testing, because this is a whole setup cost me, paid more than I should have for the pump, but the whole setup should cost you about $60. Very simple to do. Thank you.